Hey, it's Kevin Lawton with the New Warehouse Podcast here at MODEX 2022. In the booth, I am joined by Justin Warren, who is the National Sales Director at Rajant, and Don Gilbreath. He is the VP of Systems at Rajant as well. So we're going to talk about Rajant, and we're going to find out what it is that they do, and everything about kinetic mesh networks and how they apply to warehouses, warehouse automation, and how they really help us in our industry. So, guys, welcome to the show. How are you? How's the first day of MODEX going for you?
Thanks a lot. It's good. Yeah, absolutely. Lots to see, lots of booths, lots of information to take in.
Yeah, a lot of information for sure. I mean, we're looking at a packed house here, absolutely, from an exhibitor standpoint and from an attendee standpoint too. So there's a lot of things going on. So tell us a little bit about your business, what it is you guys do, and kind of how it applies to the warehousing world.
Yeah, absolutely. So Rajant, just to kind of give some backdrop on it, Rajant was really built and has built a name in the mining industry as well as in first responders and defense, because our radios, which we call them breadcrumbs, are really built to be able to fully keep a network up and operational, fully resilient, and without latency. And keeping that up, because that's critical when you think about a mining environment, or when you think about oil and gas, or when you think about military. You never want that network to drop.
Absolutely.
And it has to be wireless. And you're not always going to have Ethernet drops everywhere. You just have to have power. And that's one of the things that's uniquely different about ours, is that it truly meshes out of the box and talks to the other breadcrumbs. So it always knows where it's at. And because all of our radios are built with at least two different radios operating at different frequencies. So there's always looking for the best path. So there's less latency, it's resilient, and we do not need an Ethernet drop, for example, at every station. As long as that node has power, and we have a couple of ingress-egress points somewhere within that network, it actually will stay operational and will operate at a high capacity.
Okay. All right. So, the podcast here, we're focused on the warehouse, right?
Yes.
And we're here at MODEX as well. We're focused on material handling industry. So a lot of people listening, they're, working in the warehouse, they're warehouse operations managers, things of that nature. So tell us a little bit about, the difference between my regular network and mesh network, and what's really the difference, and what are the benefits there?
Yeah, so I think the big piece to really just take into consideration is when you look at a warehouse and you think about how things are always moving, right? You've got a stack, you may have different things that get brought in, and all of a sudden, where they may have had a wireless network put in place, all of a sudden they've got a gap in their network. All of a sudden, someone was connected before, they can't be connected now. So where we bring that difference is that because even though we can put stationary APs, we also can mount our breadcrumbs on a forklift. They can be put within robotics. And so therefore, whenever they're operating, it's always moving, and each piece becomes a node on that network. So the network is always moving, but it's always stationary, so it's always up. So if that helps to answer that question a little bit. Don, do you want to add anything to that?
I'd add, the big challenge that we see when you look at these high stacking robots that go on for 3 stories high, whatever, is they have a challenge essentially in building out where do they put their access points, they have coverage, right? So the real contrast of mesh versus, say, Wi-Fi is that when the robots themselves have some more mesh technology in them, they're not dependent on an access point. They can actually, each robot helps each other get signals out. So at the end of the day, what it results in is usually less infrastructure radios in a building than would be needed for access for Wi-Fi. And B, you've got that redundancy of essentially every robot being able to reach as many robots as peers for connectivity. And this is shown over and over, even in defense, which is about, as Justin was saying, is about half our business, where we have things on a lot of aerial platforms in the hundreds that just the radios the drones talk to each other. They actually create the network as they're flying. And so it really brings a big benefit to this group, I think, from designing the network point of view. It's just less infrastructure.
Yeah, and I think that's an important thing. And obviously working in a warehouse in that environment, and bringing more things into that environment that need to rely on, that connectivity is a huge thing. You don't want anything to drop, as you mentioned. You have gaps in the network. All of a sudden, you have a drop, and I've certainly experienced it myself as a warehouse manager. Have employees saying that, well, my productivity slowed down because I'm losing connection, right? So, being able to have a stronger connection is certainly something that is really important for us as an industry, especially I think as we even grow and move forward and we bring all these innovations into our space as well. So talk to us a little bit about how, companies are going about maybe, I guess let's start a little further back. So, companies maybe are having network issues, right? So how do they even know to identify that maybe this type of solution is something that's out there and right for them to fix the issues that they're having?
So I think there's a couple of things that happen. When you think about, no one wants to admit they have a problem with their network.
Right.
All right. Everyone wants to believe their network is working well and it's functional.
Well, I think IT doesn't want to admit there's a problem with the network.
Well said.
The operations manager wants to say, yes, there is a problem.
Yes, exactly. and the thing about it is I get it, right? People know what they know. They don't know what they don't know. So one of the things we always try to talk to them about is, tell us about some gaps in the network. Are there any areas do you have an area within that warehouse where you may have a point of failure, where you may have some issues, or it's just slower to get through?
Yeah.
And then all of a sudden they'll say, well, yeah, we had a problem here. We didn't have a problem yesterday, now we have a problem. Well, what happened?
Right.
Well, we put a new rack in, we added some stuff. Well, there's your problem, right?
Yeah.
Or they moved a workstation, and all of a sudden things have just changed. So it's identifying those instances where they may have a problem. Or they may have a temperature issue, right? Maybe they operate in low temperature, or they operate in high temperatures. We can help them with that. So if they've got refrigerated areas, for example, how do we help them with that? So, our radios can operate at neg 40 rather. So we got neg 40 there. Okay. So we can go very cold, and we can go up to 140 degrees, 80 above. So we can get pretty hot. So that's the key thing, is that we can do so many different things that the typical environment isn't going to be able to afford without a bunch of ancillaries. I think the other thing too is there's interoperability. So perhaps within where the offices are, they may already have something set up, so be it. But out in the warehouse, they need something a little bit more resilient. Yeah. So we can put that out there, but then we can also add pieces, as you just heard Don talk about, where we can put it on a robot, or we can put it on a forklift, or we can put it on an unmanned forklift, for example, where they're having to do some things. Those are the types of things that we can do to make that network more robust, where today, the only way they're going to do it is they're going to have to add another AP here, put another one there. Yeah. And that's always the fix, right? Something's not working in an area, this, just put another AP in.
Yeah, throw another one up.
All right. And then what happens if you have interference? Right. What happens if you have RF interference? That frequency's bad, so then you're playing with channels and so on and so forth. And ours is actually going to automatically look for the best throughput. And it's going to dynamically do that. So it's not something they absolutely have to do themselves. I think the other thing to also think about is people are trying to layer different technologies. I talked about that just a moment ago. So because everything's meshed, I think it's also important to note that our nodes, our breadcrumbs are actually also layer 2 switches. Okay. So it's an AP, but it's a layer 2 switch. So they can actually map their IPs and do some things a little bit differently they can't do in a traditional AP environment. And so this way, if they want to layer different technologies on top of, whether it's cameras, whether it's different IoT type solutions, or what have you, even voice, they can layer over our network.
All right, very interesting. And you mentioned in there a little bit about some interference, or some things that maybe are being added to infrastructure that could cause issues. So why don't you give us kind of like just a couple little tips about thinking about, because obviously we're looking at a time where warehouse space needs to be utilized better. We need to have more storage and things like that. Obviously, putting up racking can be an issue. So talk to us about how part of the planning process for doing these types of projects needs to involve somebody like you guys maybe, or looking at your network map as well, and that from that perspective.
You want to go ahead and talk to that?
Well, we do have various tools when we're looking at a building or an operation for planning nodes and things, but what we typically see in this industry today is, at least the group that uses traditional Wi-Fi, is they tend to throw access points around when they try to get coverage, and what that tends to do is add to the noise. It turns out in our world, at least in the mesh world, we tend to turn that down, the RF down, really. When things are bad, we actually turn the RF down, which is a little counterintuitive, but that's usually how we get this microcells to actually work and read a spectrum and keep the bandwidth up, which is what everyone wants, latency and bandwidth up.
Yeah. Very interesting stuff. And I think it's because it's probably something, speaking from the perspective of operations manager myself, I want to put more racking up, I'm going to put more racking up, but I don't necessarily think about, the network changes and things of that nature. So, I think it's great to bring awareness to that. And I think the fact that you guys are offering a less infrastructure heavy type of solution is certainly more flexible, which I think we need in our type of space as well. So it's very interesting stuff. So, what do you think is next, I guess, for the industry when it comes to networking?
I think it's just the understanding that, it's just understanding warehousing. There's not, IT departments are there, they're important, but there's a lot of outsourcing that happens. Yeah. Right? And so the understanding of, listen, this is the problem that we have, how do we fix it? I think the key is just understanding that what you've always done isn't the way to fix it. Right. There's different technology now that we can bring in and provide a real mesh network. You're not having to manually control that mesh. Yeah. And so that it'll dynamically do it. So there's actually less work they have to do. And then there's controls and things that we can provide that will actually track where assets are. We can literally put a radio on an individual. They can become a part of the network. Yeah. So there's just ways that we can put that in, and they can literally see where every asset is, where each radio where it's strategically placed. They can track materials wherever it's at, simply just through the interface that we provide them. Yeah. And so there's those tools that are available. And the other thing is where they have to do placement. So, for example, they're trying to typically mount maybe on a ceiling, maybe on a wall somewhere, and they're also having to do more cabling to bring Ethernet. They don't need as much. We can do, as long as we have one or two ingress egress points, as long as they have power, they're good. Yeah. And so that network becomes more robust the more they add to ours, where the other ones you get more latency as you start adding more radios. As you already talked about, the noise factor, right? And you're creating more interference in that network, where ours it's actually more clean. Because you have fewer nodes out there, you can make that work. And then we can just add some antennas to maybe, if necessary, tamp that out. But again, even with just the placement of, somebody built a rack and now you've got a Faraday cage in front of your radio, what do you do now? Yeah. Even if that were to happen, if they have a device, like for example on a forklift, let's just say something simple. Yeah. We've had customers that didn't even realize that AP was out and that they couldn't get connectivity because the other piece was moving. Yeah, yeah. They never saw it. There
was no drop.
So until they looked at the network, they had no idea.
Wow. That's very interesting. And I think that last point there, I think that kind of drives home the importance of that and really the proof in that, this is a robust resource and something that can really, really help you. To me, the fact that they didn't even know the AP was down, that's pretty remarkable, right? So very interesting stuff from you guys. And I really appreciate you coming by and talking to us about this thing that I think maybe from an operations manager perspective, we don't always necessarily think about because it's somewhat invisible, I guess, in a sense, right? But it's very visible when it doesn't work, obviously,
yes.
Right? So we definitely want to make sure that we're having a robust network in place and the right network in place as well, which it sounds like you guys can provide and help to be able to assess the correct needs of the operator. So thank you very much for coming by the booth. If people want to learn more about you guys, how can they do that?
They certainly can stop by our booth if they're here at the show. Okay. We're C6471 is where we're located. All right. But also just go to www.rajant.com. And they can certainly look under our solutions, and they will clearly see that we have a whole section dedicated to just warehouse automation.
Okay, great. And we'll put all that information at thenewwarehouse.com as well. So Don and Justin, thank you so much for coming by the booth today, and enjoy the rest of your show.
Thank you.
Thanks, Kevin.